Well, welcome everyone to this first technical advisory group meeting. Today we'll be discussing a DOE-led effort to develop educational materials for BEM practitioners. My name is Dimitri Contianis, the president of Model Efficiency, an energy modeling consulting firm in California. I'm the technical lead on this project, and I'll be sharing the progress we've made so far. So thanks so much to everyone for taking the time out of your busy schedules to help advise this project and really make it hopefully as successful as possible. We've got a really great group assembled, and thank you, Mike, for helping to get everyone together here today. But before we get to introducing everyone, I want to throw a question out there for everyone to think about. And no need to answer it right now. There'll be plenty of time for discussion. But this is just to get the old creative juices flowing. So how would you describe the role of energy modeler on a project? Who are we, and what are our roles on the team? What do we do? How do we do it? Why do we do it? When do we do it? And there are many answers to these questions, but at a basic level, a modeler's goal is to help inform good design decisions. And this may look different depending on the phase of the project. So in the early stages, we're trying to help inform either architectural design decisions or perhaps helping to select appropriate mechanical systems. In the middle phases of a project, mostly we're looking to refine these chosen designs. And then late in the project, we do things like documenting for code compliance, for lead, and various other things of that nature. Okay, so that's kind of a definition, but it's still very vague. And this funny definition, or fuzzy definition, makes it difficult for the design team to know how to best utilize an energy modeler. And I know many modelers who have expressed that they wish they could have a greater impact on projects. So basically, the modeling process is not very clearly defined, not just in terms of how we describe it, but also how we actually do various modeling analyses. On the flip side, though, the design process itself is extremely well defined. No two designs are the same, but the activities that occur during a design project are quite similar from one project to the next. So that brings us to today's discussion. We've conceptualized an approach to educating BEM practitioners so that they're able to provide relevant and impactful support on a design project. And to do this, we will define very specific connections between design activities and BEM activities. We will develop tutorials that teach best practices for using BEM to inform these design tasks. And we'll also be consolidating and sharing knowledge of many BEM concepts. We plan to develop an online resource to house all this information, and we've dubbed it the BEM Encyclopedia. So with that introduction, and before we get into the details, let's do a quick round of introductions. We've got a really great group with representation across several different types of professionals, including architects, engineers, modeling consultants, software developers, university professors, some recent graduates, some training providers. So really, pretty broad spectrum of participants within our technical advisory group. My name is Dimitri Contianis. I'm the technical lead on this project. And Mike, I'll let you go next, and then we can continue around the room.
Very good. Hi, everyone. Mike Wilson here. I'm the executive director for ibpsa-usa. And because our participant panels are all slightly different, I'm going to go ahead and just call out names, so stand by. Let's just start off with Aaron.
Sure. Hey, everybody. My name is Aaron Beranian. I work for Big Ladder Software in Denver, Colorado. Kind of a hybrid of energy modeling consultant and training provider. I'm kind of in charge of our training workshops, primarily for Energy Plus, but also for Open Studio, Design Builder, and CVEC Res. So hoping to bring some of that to the table in terms of crafting the material for educating everybody else in the industry.
Fantastic. Thanks, Aaron. Let's go to Tate Walker. Tate, you there? If not, here goes. Very good.
Sorry. So I'm the co-chair of AIA's 2030 commitment this year. I've been on the COAT committee, and yeah, just a big fan of energy modeling and want to see it used more in practice. Thanks.
Fantastic. Jason Glazer.
Hi, this is Jason Glazer with Guard Analytics. I'm involved in energy modeling from the development perspective with Energy Plus development team, and I'm also involved heavily with ASHRAE with being the chair of the Energy Cost Budget Subcommittee of 90.1.
Fantastic, thank you. Alfonso Hernandez.
Hello, everyone. Hi, name is Alfonso Hernandez. I'm with Gensler. I do everything building performance with them, solar, daylight, energy, CFD, whatever the team actually wants me to do. And I'm also a teacher at the University of Houston, the grad level in architecture, teaching environmental technology and building performance. I'm also part of ibpsa Houston and the daylighting committee of ISNA.
Fantastic, thank you.
Yeah.
Andrew Corney.
Yeah, hi everyone. I'm Andrew. I was a consultant for 13 years in energy modeling with WSP in Australia and California. But now the last 7 years I've been at SketchUp, working mainly as the product manager for the Sapphira product, but also for other products within the SketchUp universe.
Thank you. Let's go to Allison Kwok. Allison.
Hi, everybody. I am Allison. Nice to see some familiar faces on this. I teach at the University of Oregon, and I guess I would say I'm an energy modeling enabler. I don't do it myself, but I make my students learn it. And so I'm looking forward to connecting to the education piece on this.
Thank you, Allison. Next, Amir.
Hi, I'm Amir Roth from DOE. Just a couple points of clarification. DOE is not leading this project. DOE doesn't actually lead too many things. We are sponsoring this project. Yeah, I won't go through the whole litany of modeling things that DOE is supporting, but this is one of our kind of newest ventures. You know, if any of you over the last year and some, actually probably a little longer than that now, I've been helping AIA with the energy modeling design guide. I think as part of the experience of that effort and my frustration and confusion with it, I think we decided to, you know, try to do something that would be a little more robust, a little more kind of flexible, a little more dynamic, and a little more helpful. And so that's really the genesis of this effort.
Thanks, Amir. We do appreciate your support. Let's move on to Andrea. Andrea Love.
Hi, I'm Andrea Love. I am principal at Payette in Boston. We're an architecture firm, and I lead our building science group, which handles all of our internal modeling and sustainability. And then similar to Tate, I've been on the code advisory group and am very involved in the AIA 2030 working group.
Fantastic, thank you. Bill Burke. Bill, you're next.
Hi, I'm Bill Burke. I'm an architect. I was at the PG&E Pacific Energy Center for about 22 years doing educational programs there. I know and similar to Allison, I'm an enabler, trying to get architects to understand how to use energy modeling and also getting them to understand when they need to get somebody who really knows what they're doing about modeling. So I just retired July 1. So I'm now actually pretty actively working with AIA California on their committee on the environment. So I'm still involved, but I'm retired from PG&E.
Thanks, Bill. Let's go to Bob. Bob Fassbender.
Hi, I'm logged in twice, so trying to figure out which one to unmute. Bob Fassbender, and I like long walks on the beach. I don't know how I got on this meeting, but I am, I guess, someone who's been promoting energy modeling for some time to broad audiences. Lately, I've been doing instruction, but also a lot of large models, myself. So really in depth into a number of different practices from design all the way through ESCO services.
Thank you, Bob. Cindy Renier.
Hi, everyone. I'm Cindy Renier. I'm with Lawrence Berkeley National Lab. We're the managing lab for this research project. And I'm actually a mechanical engineer by training. I used to be an energy modeler. So looking forward to the discussion and supporting the project.
Thank you. Corey Duggan.
Hi, everybody. Corey Duggan with TLC Engineering Solutions. I am, we're like a 400-person consulting engineering firm. I lead our energy modeling, building performance practice, doing both modeling and consulting with architectural teams where we are the engineer and where we're not the engineer, as well as doing all of our internal training, trying to get all our staff on the same page and raising up our capabilities.
Thanks, Corey. Let's go to Daniel Overby.
Hey everybody, Daniel Overby, Assistant Professor at Ball State University and Director of Sustainability at Browning Day in Indianapolis. I'm an architect there and am constantly, either with students or colleagues, trying to find better pathways of building energy modeling into our workflows. And it's a constant struggle in my market and including with the engineers that we engage. And so really happy to be a part of this team.
Thanks, Daniel. Let's go to David Goldwasser. Maybe unmute. All right, we'll skip David and come back to you.
Can you all hear me now?
There we go. Hi, David.
Sorry, I was on the phone, so I unmuted my phone, but I didn't unmute the computer as well. So anyway, sorry for that. My background is architectural and construction management, both by training and by profession, up until 10 years ago when I started at the National Renewable Energy Lab, where I'm still at today. And I do software development as well as research into building science. I should also point out I'm on the board of directors of ibpsa-usa as well.
Thanks, David. Let's go to Elnaz Tafrigi.
Yes, hi. Can you guys hear me?
We can.
Yes. So my name is Elnaz Tafrigi Bailey. I'm a PhD student at UC Berkeley. I developed AR and VR experiences during my PhD. So I worked mostly on the software side, but before I worked in an architecture firm and I worked as an in-house, actually, sustainability consultant. So I did energy modeling, and I also studied master in design studies in energy and environments before, and my background is in architecture. And I see some familiar faces, so hi everyone.
Fantastic, thanks Elnaz. Let's go to Eric Coldrup.
Yeah, hi, Eric Coldrup. So I'm an energy modeler based in Northern California. I also teach a building systems class at Stanford that includes some energy modeling, and I've done quite a bit of energy modeling training over the years.
Thanks, Eric. Let's go to Heather. Heather Jar. Can you? You got to tell me how to say your last name.
Yeah. Hi, everyone. Heather Howergy. I work with Perkins Eastman, and I'm on the firm-wide sustainability team as an in-house sustainability specialist. And I interface with energy modeling in a variety of different ways. We use in-house tools to inform design decisions, both within our team, but I'm also doing extensive training across the company to make sure we're incorporating energy modeling and a variety of other performance analysis tools into our design decisions. And then also, of course, interfacing with out-of-house consultants around energy modeling as well.
Fantastic. Thank you, Heather. Ian Malloy.
Yep. Thanks, Mike. Yeah, Ian Malloy. I'm the product line manager with the Autodesk Building Group. I lead the development of Revit for building performance analysis and MEP.
Thanks, Ian. Let's go to Jayati Jabbar.
Hello everyone, my name is Jayati Chawla and I am a licensed architect in India and currently pursuing MS in architecture and high performance buildings from Georgia Tech. And I'm currently researching on carbon sequestration techniques under Professor Tariq Rakha. And it's an honor to be here with all of you experienced professionals, and I hope to learn a lot and maybe contribute a little. Thank you.
Thanks, Jyoti. Let's go to Kapil.
Hey everyone, hope you can hear me.
Yep.
We can.
Awesome. This is Kapil Upadhyay at Kirksey Architecture. I lead the building physics team out here. I just want to mention that it's been 12 years since I first attended same build back in UC Berkeley. And I just joined Kirksey as an energy modeler, and I realized, oh my God, energy modeling is just the tip of the iceberg. So over these years, I've been trying to just support sustainability across different teams, primarily in Texas. And just last year, as a firm, we realized building physics itself as a profession, a specialty that can support building design. So I've just been, since last year, being focused on building physics as an independent sort of specialty in the architectural and building industry. So thank you.
Thanks, Kapil. Let's go to Kevin. Kevin Zettelmeyer.
Hi, this is Kevin Zettelmeyer. I'm with Sustainable IQ. I'm also a second part of this project that is looking at building energy modeling deep design data. And so looking at how we carry understanding of energy modeling farther based on the information that's captured, and how we can start to bring together a larger data set to be able to analyze that and have it be an open framework. So great to hear a number of the voices that I recognize and see some of you, and glad to be a part of it.
Thanks, Kevin. Let's go to Kristen Parrish. Kristen?
Hi, everyone. I'm Kristen Parrish. I am a professor at Arizona State in the School of Construction, and I will say I'm like Allison, an energy modeling enabler. I require my students to do it in 2 of my classes, and about half of my PhD students do it as well.
Thank you, Kristen. Let's go to Liam Buckley.
Thanks, Mike. Hi, my name is Liam Buckley. I'm an ibpsa-usa member. I'm also Vice President of IESV Software in North America. I teach building energy modeling, daylighting, CFD, energy code compliance for IES. I also teach building energy efficiency at San Francisco State University in the Master's Engineering program. That's all I got.
Thank you. Let's go to Madison. Madison Prince.
Hey everybody, I'm Madison. I'm entering my last semester at, same as Jyoti, the High Performance Building Lab at Georgia Tech. So lots to learn, happy to be here, and hopefully help in any way I can. So, thanks.
Fantastic, good to have you here. Mohammad Kashivarzi. I'm sorry.
Yeah, it's Kashivarzi. Hi everyone, great to be here. I'm Mohammad Kashivarzi. I'm a PhD student at UC Berkeley. I mostly work on generative design, software development. I've been previously working with the generative design AEC team at Autodesk, and I love making tools. Also, right now, my focus is also on VR and AR interfaces for new building performance modeling and generative design tools.
Fantastic. Thanks, Mohammed. Let's go to Pablo LaRoche.
Hello, everybody. Happy to be here and good to see many of you. I wear a couple of hats. One of them is as a professor of architecture at Cal Poly Pomona, also as interim director of the Lyle Center at Cal Poly. And I really try to have one of the classes that I teach is in environmental control systems, 140 or 150 students, and I have them do modeling. These are second-year students. We even using simple programs like heat or just a portion of Sapphire like daylight, but just having them get the introduction to modeling the ideas that they're testing. I also work at Callison RTKL, where I had their sustainability group, and we do a lot of building simulation. And I remember the first time I used a modeling program, which was actually a French program called Codiba. That was in the 90s. It was, I just remember the moment in which I could simulate like night ventilation. I thought that was
so cool. I mean, just that could actually plot that. So I think this is super important to have architects and designers use building simulation as much as possible.
Thanks, Pablo. We're glad to have you. Let's go to Rand Ekman.
Yes, hello. I'm Rand Ekman. I am Chief Safety Officer for HKS, big firm, many offices around the world. So I love the term enabler. I would add on to that I, in addition to doing that, I tend to find myself kind of an activist for not just the doing, but the doing with a deliberate sort of betterment of architecture. And I'm also pretty interested not just in the sort of technical aspects of modeling, but creating the right behaviors. So this is quite interesting to me.
Thanks, Rand. Let's go to Raunak Chibrawala. Raunak?
Hi. Hi, everyone. This is Raunak Chibrawala. Yeah, I'm a recent graduate of Georgia Tech High Performance Building Program, and I also work at EYP Architecture and Engineering as Building Performance Analyst. We do a lot of environmental modeling to energy modeling to daylight simulations for our design at various stages. And my particular research interest is basically how can we quantify uncertainty in design phases and tie them up with building energy modeling.
Fantastic, thank you. Stacy White.
Hi there, it's Stacy White. I'm an architect and a faculty at Cal Poly San Luis Obispo, and I have a dog trying to defend my porch from the mailman.
We're all familiar with that. Tate Walker.
I'll go again if you want.
Oh, there we are. I'm just running down this list here. Teresa Rainey, please.
Good afternoon. I'm Teresa Rainey. I'm with Director of Engineering and High Performance Design at EYP, Architecture and Engineers. So I have been a huge proponent, being a mechanical engineer, about getting energy modeling early. So being in an AE firm has really helped me work with the teams to identify the right tools. Again, much to what Dimitri said, you know, what we're using at different stages, it's different tools, different timelines. I'm thrilled to be part of this because I think it's just critically important to get that education out.
Thanks, Teresa, appreciate that. Valerie Green.
Can you hear me now?
We can, thank you.
Okay, hi, I'm Valerie. I'm in my final month of graduate school at UC Berkeley. I previously worked as a building enclosure consultant and now do research with Lawrence Berkeley Lab related to thermal modeling of building enclosures, with one of the goals being more accurate inputs for energy modeling.
Thanks, Valerie. Vikram Sami.
Yeah, hi. I'm Vikram Sami. I'm the Director of Building Performance at Olson Kundig. We're a 200-person architecture firm in Seattle. And I'm trained as an energy modeler and I'm a licensed architect. So I kind of tread both worlds. And I would say my role is really as a kind of an instigator, a provocateur, if you will. And I currently serve on the Code AG. You know, I overlapped with Tate for 1 year, and Tate forgot to mention that he was actually one of the co-authors of the Code Top 10 Toolkit. And I helped a little bit with that. And then I served for a number of years as on the technical advisory committee of the ASHRAE Energy Modeling Conference, and a few years ago, the ibpsa-ASHRAE conference as well. So yeah, I'm very passionate about building performance, all kinds of building performance modeling, but also about design, and I kind of tread both worlds.
Thanks, Vikram. Good to have you here. Next, we have Wanhee Ko. Wanhee?
Hello, everyone. I'm a PhD candidate at UC Berkeley with Center for Built Environment. I'm working on comfort-based building metrics and the development of simulation workflow. Before joining the program, I used to work at Bureau Uphold Engineering as a consultant, and I'm happy to be part of this team.
Thank you, Wanhee. Let's go to Wyatt Siddharth.
Hi, I'm Wyatt Sutterth. I am a mechanical engineer at HDR, based out of our Omaha headquarters. I'm actually in Iowa City remote for the next 2 years. I am mechanical engineer background. The last about year and a half has been more focused on energy modeling and how we can incorporate that more effectively with our architecture into early design processes, and then being able to carry that throughout the project. I'm also very interested in helping to start automate a lot of our Revit design processes through Dynamo, Python, different coding options like that. So glad to be here.
Thanks, Wyatt. Let's go to Yasser El-Masri. Yasser?
Yes, hello, Mike. I'm Yasser El-Masri. I'm an architect from Lebanon. I came on a Fulbright scholarship to the United States. I did my master in sustainable design at UT Austin, and now I'm doing my PhD at Georgia Tech in the HPBL, the High Performance Building Lab. I'm actually working on the DOE-funded BEM project, which works with drones and thermal imaging to create and model buildings and BEM models. My interests are non-destructive techniques and how we can actually model defects and deterioration of envelopes over time in a simulation, and I'm working on that currently for my PhD. One fun fact, one of my proudest moments in this entire world is that I got Professor Alison Cloak to sign my copy of Passive House Details, so I hold that book very dearly. And that was my crowning achievement so far. And I hope I can get, other books and other signings too. Thank you.
Great. Yuming Xu?
Yeah, hi everybody. My name is Yuming, and I'm a second-year master student in Building Science group in the Department of Architecture at UC Berkeley. And I was trained as a civil engineer at UC Davis in my undergrad. I learned some basic BEM software in the class I took in Berkeley last year. I'm currently self-learning some other BEM tools, and I'm really excited about this project and can be part of this amazing team. Yeah.
Great to have you, Yuming. Last, we have Ronak Tibrewala.
I already did mine. I actually joined twice.
You popped at the end of my list, so.
Yeah, I actually joined twice, yeah.
Okay, great. I'm going to hand it back to Dimitri. Thanks to everybody for
putting
the cameras on.
Mike, I joined late, Mike. Can you hear me?
Oh, Chell. Okay, let's go to Chell first. Chell?
And somebody else as well. So I'm Chell Anderson. I wrote a book on energy modeling from an architect's viewpoint about, 8 years ago or so, design energy simulation for architects. I'm on the State Building Code Council and the Energy Code TAG Chair for Washington State. And I'm on the AI National Energy Leadership Group, and have been wrestling with the user end of architectural simulation or design energy simulation for 2 decades of my career. Also on the Project Stasio group. So we're trying to pair, not through the BEM side, but through the graphic side, questions and answers through that.
Thanks, Chell. One other person who's on the phone, I'm not sure who you are. Introduce yourself, please.
Could you? Can you hear me?
Yes, we can.
Oh, great. I'm Greg Mella, and I'm in a cabin in the woods with spotty internet connection. So I'm thrilled that you can hear me, and I'm humbled to be part of this amazing group of friends and energy modeling rock stars. I'm the Director of Sustainable Design for Smith Group. We are a large architectural and engineering firm. And in my role, we also have a building performance analysis group. And really my role is to kind of work with every project team at some point early in the design process to integrate the building performance analysis group with their design projects, to guide them to identify the kinds of analysis and simulations that align with the project goals and that would advance the project. So in that sense, I'm a bit of an energy modeler, enabler myself. And again, I'm thrilled to be part of this group.
Okay, and then I think we have one more. Ali, are you here?
Yes, I'm here. Can you hear me?
Yes.
Hi. Hi, everyone. I'm Ali Menchaca. I'm a vice president at Thornton Tomasetti and the sustainability practice. I focus on building analytics. I do some energy, but mostly specialize on comfort and answering unique questions using energy modeling. I used to be part of ibpsa Boston. I'm highly involved with ASHRAE, and I'm about to stand down as co-chair in Boston because I relocated to France 4 days ago. So I'm calling in from Toulouse, France. I am just honored to be part of this all-star team. I'm just in awe, and this is like the best party I've been to since March. So happy to see so many familiar faces and meet so many of you. I did my I got a PhD in mechanical engineering at MIT and really focused on, making sure or convincing myself that mechanical engineers are right, architects are wrong. Then I joined an architecture firm and convinced myself that consultants are wrong, that architects are right. And then became a consultant and have come to realize that we're all just not communicating very well. That we're all trying our best, but it's, communications are challenging. And so I've become really passionate about improving communication between performance and design. And I'm also a founder of Project Fazio, as many of the people here. Very excited to be here.
Fantastic. Thanks, Ali. So I'm going to hand it off to Dimitri to attempt to catch up on our agenda.
All righty, great. So as you can see, I wasn't kidding. We've got a really great group, lots of different stakeholder groups. I guess I did neglect to put on my list that we've got lots of enablers and provocateurs as well. So I'll update my notes for next time. But thank you everyone again for being a part of this project. So a major motivation to focus on this educational effort came from a series of interviews that many of you participated in last year. We were trying to gain a better understanding of how practitioners are using BEM, what kinds of studies are you doing, what tools are you using, and so forth. One of the questions we posed was, how are practitioners learning BEM? And this is what we learned. And we had a pretty experienced group in our interviews, as you can see by the number who gained their modeling expertise while pursuing advanced degrees, but very few learned about BEM and building science during undergrad. For most, there was this sort of hodgepodge approach to piecing together an understanding of how to do energy modeling. Many of us experienced that firsthand, and many others are going through that process right now. During the interviews, we captured some of the interesting comments that the interviewees noted to us. So you can see, I've highlighted a few here. Folks said there's no go-to resource to learn BEM. That last slide kind of showed there are resources, but they're scattered a little bit. Folks tended to agree that software vendors provide good training content, but there's not really a great resource that's focused on fundamental concepts. And then this last one, training is most effective when knowledge can immediately be used on a project. That one really resonated with me, and it's really been a guiding principle for what I'll be sharing with you today. So the first step in this new project was to do a deep dive and assess what information is out there already. So we did this research phase where we looked at a broad range of content in several categories, including online resources. Some of them focused on BEM information, some of them kind of more broadly focused on the design process and elements of designing buildings. We looked at publications, including white papers, books, textbooks, modeling guides for codes and standards and utility incentive programs. And we dug up some video training, doing a little YouTube scouring. We looked at many available training seminars, and these could be either in-person or online seminars. We looked at some resources available for people who wish to teach energy modeling. And then, we also looked at what the software companies are providing as well. So this research really showed us that there's definitely quite a bit of information out there if you know where to look, but much of it is geared towards teaching a specific tool or documenting advanced use cases, like in white papers, for example. There isn't really much content out there that's easily accessible, that's focused on teaching fundamental concepts. So less experienced modelers may not fully understand the design process, how BEM interplays with the design process, the underlying building physics principles that simulations are trying to represent. So, what we did was take this research and we consolidated a list of links, which is, at this link here, bemcyclopedia.com/links. I'll really quickly show you, what we've got here. Hopefully you can still see my screen. Can you still see this, guys?
Yes.
Okay, awesome. So you can see, you know, we basically have a bunch of different categories that I just showed you on the screen. So, you know, under the BEM and design resources, you know, a lot of these are going to look familiar to you. Some of them, like I said, are modeling specific. Some of them are more design focused. You know, we can kind of click on any of these categories and see a bunch of reports, technical docs. You know, for each one of the resources on this page, we have, you know, the name, you know, where it came from. I wrote this short little blurb describing what you can find here. And then we've also indicated whether this content is free or whether you need to pay to access it. So I definitely, you know, invite you guys to check this out. If you find that anything is missing, you can see at the top of the page, there's a little link you can click here and say, well, you can either submit ideas for additional links, or if you're affiliated with one of these resources and you don't like the little blurb I wrote, then please, you know, send me a suggestion on what we can do to improve the description. Okay, so go back to the PowerPoint here. Okay, so those are the links, and I hope you guys find it helpful. But in my opinion, you know, just consolidating these existing links isn't really going far enough. There are lots of resources. I think, you know, that page has about 100 links. So, you know, there's definitely information out there. But, you know, each of those resources will kind of teach you bits and pieces of what you need to know. But it's up to you, the modeler, to make the connections yourself and sort of piece together a more full understanding of, you know, what you should do and when. So, you know, that's easier said than done, especially for beginners, and therefore they may struggle to interpret the results that are coming out of the software. And, you know, I think we all know that it's sometimes very difficult to communicate the results in a way that is meaningful to a project team. So that, you know, provides a bit of background on how we decided to move forward with this new BEM education concept. The goal of this project is to teach practitioners to perform meaningful modeling tasks, help them to interpret the results more confidently, and communicate the results effectively. Now, I do think it's important to note that there have been some past attempts to consolidate BEM information that have sort of fizzled out over time. So how can we build and maintain momentum for this project? Now, this is not the primary topic for today, but I did want to raise it so that we can begin to think about it, and then we can address this during a future TAG meeting. As a starting point, you know, the approach we're going to take initially with this project is to develop content that can stand alone, but each piece will sort of build towards something more comprehensive. And I think in that way, we can, you know, over time, create something, you know, quite powerful. So thanks for listening to the background information. Now let's get to work. Your job today as technical advisors is to help guide the project's conceptual design and help to prioritize the early work tasks. I'm going to take some time to walk you through our early design concepts and then ask for your input on 3 specific topics. You know, 1, organization of the materials, 2, the scope of the content, and 3, help to prioritize content development. Okay, so we'll start with topic number 1, organization of this website. We've come up with this concept of organizing the educational content so that it's really well aligned with the project's timeline. In this way, we can provide content that is both timely and relevant to whatever project you happen to be working on and need some support on. The content itself is designed to provide a very clear connection between specific design tasks and supporting modeling tasks that will inform those design tasks. We also hope to provide modelers a better understanding of building science principles, provide guidance on specific modeling steps and scenarios that you might wish to investigate at various stages of the design, and finally, guidance on how to analyze and present results to the design team. So again, you know, this is based on feedback we kept hearing that training is most effective when you can use that knowledge right away. Okay, so.
I have a question.
Yeah, sure.
Is the target audience someone who is learning to be a professional building energy modeler? Is that the correct assumption?
Yes, but the hope is that this can also be valuable to people who have been doing it for some time and, you know, wish to brush up their skills or, you know, get a better understanding of how models work, how buildings work, and how those two may or may not be the same, so that they can really understand what's going on, underneath the hood a little bit, and that will help to, make sure you can analyze your results effectively.
Okay.
That's definitely, an area where I'll be asking, later on for, how deep should we go? So I definitely look forward to some feedback when we get to that. Okay, so let me show you a bit of how this is all going to work. And before I, give you an overview of the prototypes we've developed, I want to talk a little bit first. As the first step, what we did was we went through this process of analyzing the activities of a typical design project, and then trying to map modeling tasks to those design activities. So I'm going to toggle over here if I can to my other screen. You can see what we've got here is this, beautiful mind map, but essentially what we're looking at is a project timeline. So you can see along the timeline, we've got the major stages of a design project: pre-design, conceptual design, schematic, DD, etc. Now, within each of these design phases, the design team has several tasks that they need to perform as part of the design process. So in pre-design, the design team may be performing a site analysis, code analysis to figure out which codes apply, begin the building programming process, and setting various goals and targets for the project. So within each of these sort of major design tasks, what we then did was begin to list out some things that a modeler could or potentially should be doing to help to inform that particular design task. So site analysis is going on. The modeler can help to evaluate the climate at the site location, evaluate solar availability, look at the impact of various site constraints. During the code analysis phase, they can help to figure out which codes apply for energy, ventilation requirements, and begin to surface some of the salient points that are in a beyond code program and so forth. For the project goals and targets, you may be doing some EUI benchmarking or helping to set an EUI target for your specific project. So that's a few examples. In conceptual design, the design team may be hosting design charrettes. They begin to design the form and mass of the project, and then begin to come up with various design concepts. So again, the modeler has a number of things that they can do to assist with these tasks. During the design charrette process, they may help to brainstorm and vet the applicability of various energy conservation measures. They can run some scenarios and simulations either before, during, or after a design charrette. If you can begin to do some massing option simulation analysis and begin to look at, as you get into the later stages of design, the tasks get to be a bit more involved, more complicated. There's a lot more things that you can be doing to inform the design, and this can look like full building models. There can be shoebox models, and I'm not gonna read all these off to you now, but I do plan to share this diagram with you, and would love to get your feedback on whether this looks good, what might be missing, how we can maybe structure it in a way that's as user-friendly as possible. So this was a first attempt to map energy modeling tasks directly to tasks that the design team is trying to accomplish. Okay, so
is this aligned at all around ASHRAE 209?
Yeah, so I've actually begun a mapping process to the ASHRAE 209 phases as well. I will share an example of what that looks like as well. Actually, I'm going to get to that right now. But I do think that is important. ASHRAE 209 has done some great work to map out where energy modeling fits into the design process, and I want to make sure that that is captured as well. Okay, so now we're looking at a very early prototype of how this content could be organized on a web page. And you can see there's a few different ways to navigate, but first I'm really going to focus on this learn by design task. This is sort of the primary way that I envision people would use this resource. So, much like that timeline diagram, we allow users to browse by design phase. So, you pick your design phase that your project is in. And the goal here is like, well, if I'm in pre-design, what can I be doing to help out the project? So we click in here, and it will load. Okay, and you see again, we've got these major design tasks: site analysis, code analysis, etc. I want to give you a quick example of what content we hope to provide under each of these modeling tasks. So I mocked up an example of what a climate analysis might look like. So if you're the modeler and you've been asked to do a climate analysis for your design team, what should you be doing? All right, so we start these tutorials by talking a little bit about, well, why am I actually doing this? What are the analysis objectives? So, I have a little discussion on that. Climate analysis during pre-design helps provide an understanding of how the local weather conditions will impact the building's design and performance. And you can see, we highlight some things like it may have impacts on the occupant's thermal comfort. It might inform passive design strategies. And, any of these sort of links could be clicked for more information on that particular topic. It's kind of like the Wikipedia approach, where you can, go down the rabbit hole as deep as you want to go. But under this analysis objectives, we talk about some concepts that you may wish to explore. So one thing you might want to look at is, when is the weather comfortable? Do operable windows make sense for this project? You may wish to look at the availability and intensity of solar radiation. Do we need to control solar gains? Should we consider solar generation from PV panels? And there's some other things here, like looking at prevailing wind conditions. Are there any special things I need to do to comply with a code or standard? And this is actually where the 209 tie-in comes, but we'll get to that as we go through. So, for each of these tutorials, we kind of start by talking about, well, what do we need to know and do first? So talk a little bit about how climate analysis during the pre-design phase is typically performed by analyzing an hourly weather data file. For this tutorial, we kind of look at Energy Plus weather files, but there's a bit of a discussion here about other types of weather data that you may wish to perform. And I do want to click this too, just to sort of show you what the linking to more detailed information might look like. So we want to see, well, what are they talking about? Weather data. So here we have a little bit of a discussion on different types of weather data that's out there, helping people to understand typical year weather data, actual weather data, future weather data, and design day weather data. And what are they? When may you wish to use them? So again, we can sort of drill down to that next level if we wish. Okay, so carrying on, the first step here is get your project's local weather data file. We provide some links on where you can download Energy Plus weather files. We also have some links to other sources. This is where you might be able to find some of those actual weather files or future weather files. And then, after we kind of get this introductory stuff out of the way, what do we need to do to perform the analysis? What are the inputs that are required? Now, this is a pretty simple example where there aren't very many inputs required. The input is essentially the weather file. Most of the work that you're doing in this example is the actual analysis. But for more, involved analyses, this is where we sort of list out the steps. Collect the insulation levels from your wall sections, etc. So we have a bit of a discussion here, though, on what may be an appropriate software tool to use. We share, what you need to do next, which is open the weather file. Talk a little bit about some advanced use cases and potentially link off to other tutorials from there. But the vast majority of this particular example is analyzing the results. And basically, let me close out some of these things so you can sort of see how it's organized. All of those analysis objectives that I had listed at the top have a fairly lengthy discussion on how do you actually answer this particular analysis question. So this first one, when is the weather comfortable and do operable windows make sense? We sort of break down each of these analysis questions into a few different chunks of information, starting with building science and design concepts. And what do I need to know about how buildings react to the weather? What are some things that are going on during the design process that I should be aware of so that I can provide relevant information? And if we expand this out, we can see there's a bit of a discussion here. Operable windows can provide free cooling and natural ventilation with no need for HVAC when outdoor conditions are appropriate. Now, we talk a little bit about how this is in some part based on the temperature conditions outside. but also you may wish to look at the wind conditions to make sure that you get adequate airflow. And that's actually described a little bit further below in this example. So we, basically provide some more information. When it's too hot or too cold, you should close the windows and let the HVAC system run. If you have a building that has operable windows and HVAC systems, we provide a bit of a discussion about mixed mode systems and things you ought to know about how to make sure you're not wasting energy by leaving the windows open when the systems are running. So again, this is the background information that you should understand about how buildings actually work when the windows are open and how they react to the weather conditions. We then go on to discuss.
I love the format in being question-based. I think that's brilliant and great. I think having like limitations or caveats would be good associated with each of these, such as, there's also like dust storms and bugs outside, when you talk about natural ventilation, but also that, wind is captured at 10 meters in the air and not at ground level and airports and that kind of stuff.
Yeah, I think it would be, so there's a couple of thoughts. I think it's probably worth, if you look at these different metrics, this, temperature, humidity, wind and radiation, which one of these, because these are taken at, very often at the airport or somewhere not your site. And so actually thinking about which ones will actually vary on your site and which ones are more reliable to what you would see on your actual building is important. And wind is one where, actual results may vary a lot. So, I always like to throw in a caveat when we talk about, windroses and stuff, that it's a windrose at the airport. It's not a windrose at, wherever you are. So actually thinking about that. The other thing, and this is a personal pet peeve with operable windows, I think framing the question, not are operable windows appropriate, but maybe framing it to say when are operable windows. It's a simple taxonomy, but it changes the intention of it to say, hey, we think, it's worth studying, but it might, look for what times of the year that it's appropriate. Does that make sense?
Absolutely. Yeah, this is great feedback. I will note that this is very much in draft form, really designed to illustrate the concepts and not to be like, this is not the final version, or your input will be greatly appreciated as we work towards finalizing these examples.
Dimitri, regarding the input, so how do you imagine we give you the input? Should after each of these meetings we write a document, for example, and submit it to you? How do you, that wasn't just clear enough for me. Can you just explain how you expect us to give you feedback and how you were going to incorporate that?
Yeah. So the first thing that I'm going to be looking for feedback on is really what I showed you previously, this timeline graphic. Look at the design tasks. Have I captured ones that can be well informed by modeling tasks? And then, have I mapped the appropriate modeling tasks to each design task? That's definitely gonna be the first thing that I'll be looking for feedback on, is really trying to get this, as right as possible or as robust as possible. Reviewing this content will come later because this is meant to be illustrative, not meant to be final. What we'll be looking for your feedback on later today is how should we prioritize the development of this type of detailed content? And then, we'll kind of go off and develop some examples and some drafts prior to the next TAG meeting. And at that stage, we'll share draft content with you. We'll look for any markup copies or whatever format will work best.
And my comment was not to pick on certain technical aspects, but to say that there's a limitations or caveats section for each of these that talks about what other considerations that can't be really adequately captured in a kind of a general how-to guide.
Right. No, I think that's a great point. And we're definitely, taking note of all your feedback here today so we can make this as robust and useful as possible.
Sorry to interrupt. I just had a question. Do we have any previous books on these topics? And how is this going to be different from that? Obviously, it is going to have links and they can learn more about it. But do we have previous studies on these, which have all of these things combined in one?
I don't believe so. If it exists, I don't think we found it yet.
All right. Okay.
So
Vikram's showing us his.
Yeah, this is Ali. I'm going to add to Jayadi's. I think I think we'll all start getting into this and I guess understanding a little bit more of the scope as we see more and more of it. But I think that one of the things that might be worth considering is how much of this is a guide to teach how to do modeling versus how much is this a building science or a design guide, right? Because it's very easy to go down the path. As someone who has done natural ventilation a fair amount, I could think of 5 chapters on like how certain things are going to work, but certain things are not going to work, and it's like very specific. And so I tend to be a little bit more cautious about the guidance I give, but at the same time, I would love it if people understood why the windrows matter sometimes and doesn't matter some others, right? And so I think that just outlining that very clearly in terms of what the specific goals are of the website and the document is going to make it much easier for us to provide feedback that is useful to the purpose and not necessarily feedback that is related to the content, but where the content does not necessarily, support the purpose in a way. Just because you can end up down a very, very, each one of these topics could lead to, there's hundreds of papers written about them. There's many books written about them. But at the same time, we want to make sure we give basic info. So understanding what the underlying goals are is going to be very useful, and just reminding us of those is going to be extremely useful.
And to piggyback on Ali's point, I mean, Dimitri, could you envision this being a wiki type of resource that other people could contribute to, and it can shift and evolve over time, or is it something that'll be curated?
I think ultimately it's not something that one person or even a small group of people can develop, to cover the vast scope, that we're talking about, whatever scope we decide is appropriate. So, that's something that I think we'll need to continue to explore. Most likely, crowdsourcing would be great, but how can you do so in a way where the content is well vetted, and that's something maybe we think about and we can address during a future tag meeting.
And Dimitri, I really think we should truly identify our audience, and if we can have like different paths. So like some websites where when you enter the website, you pick, what are you? Are you a student? Are you a modeler? Because the thing is, I'm trying to think of how we can make this kind of unorthodox. Because a lot of these, like the references and these things, I mean, there's even the Energy Plus guide for tips for modeling, and it has kind of this kind of thing, which is there's a question and there's an answer under that one, which is part of the official documentation. So what I'm trying to think of, like maybe this can be kind of a parallel curriculum to someone studying if this is a student, and how they can go through it, like kind of it's a hand-in-hand guide. I mean, these are just ideas, but I'm trying to trying to take it in a way that it's kind of a tunnel approach, not just you have access to everything, because you're going to get lost in those, and that's kind of one way we can take it.
Yeah, some of the thoughts I've had on that are, you can provide some information that would filter this down to things that might be relevant to you. So if you're an architect, you probably don't want to look at how to optimize the HVAC control sequence, and you can kind of cut all that content out. Another thing that I've kicked around is maybe you can have a little questionnaire when you log into the site.
Exactly.
Asking about your project, and you could enter in some information about some decisions that have already been made, some constraints on the site, and then it could filter it down further from there. So there are some things that could be done, and these are definitely things we're still exploring.
Awesome.
Okay, well, I'm gonna keep chugging along. There definitely will be time to provide more feedback. So I don't want to cut anyone off, but I want to make sure I can just kind of keep walking you through the sort of framework of what these tutorials would look like. So under the analysis steps, we talk a little bit about what data we should be looking at in this weather file, how to filter the data down. Maybe you wish to filter it to only include occupied hours, how you could determine which hours of the year fall within those acceptable comfort ranges, either like a simple approach or a more complex approach. Talk about 2 different ways. And then finally, how do you present the analysis? And this, we say that presentation of the analysis should clearly answer the question, how often is the outdoor weather comfortable? And we give, a little graphical illustration of how you can convey this. I'm sure there are other examples that could and should be included in a final version, but the idea is that we give the users some ideas on how they can convey this information effectively to the design team. So then, some other quick examples, solar radiation. Again, we start by discussing building science and design concepts. What is the appropriate data? How to review the data. And this one, actually, I do talk a bit about some limitations, I talk about at this stage, we're really just trying to understand how the sun impacts your site, but later on in design, we should actually be testing different designs and different strategies to really understand this as it applies to your building. So this kind of picks up on a point that was made earlier. So again, we can provide some example imagery that helps people to understand what's going on, and talk a bit about how we present the analysis. So, for each of the design questions, it follows a very similar format. We kind of have those main subcategories, the building science, the analysis steps, and how to present the analysis. The last one here is where I pick up on the ASHRAE 209 requirements. What code requirements do I need to follow? And it talks about how there are some mandatory requirements in ASHRAE Standard 209 for capturing and reporting on climate conditions. So, there's quite a bit contained in this example of climate analysis, which is, one of the simpler analyses you can do as a modeler, but there's quite a bit involved. So it's important to kind of convey that information in a way that can be meaningfully applied to the team. There's some placeholder sections here as well. What should we be thinking about for future design phases? So this kind of gets you thinking about what questions to ask your design team next. It may help to spur ongoing discussions with the design team. And then finally, some additional resources. We have some links to various tutorials, articles, detailed technical documentation. So a lot kind of gets covered in this, in each of these examples. So, basically, going back to the main page, if we were to navigate to conceptual design, it's kind of organized the same way. We have our sort of main design tasks, and then the associated modeling tasks that help to inform that design task. This is kind of placeholder content now, but I think at this stage, you probably have a pretty good understanding of how we're thinking about organizing the material and what an example of that material may look like. As I mentioned at the beginning, this may be the main way to navigate the content by design phase, but there are some things that you need to know that don't fit neatly into a particular design task. So these are what I'm calling the essential concepts. This can be like, what are the parts and pieces of a BEM model? What are some HVAC and heat transfer concepts you need to know? Maybe some detailed discussion on various energy conservation measures, and some guidance on how to pick the right ones to analyze at different phases of the design. This search by topic is basically allowing you to search the sort of broader wiki of information beyond the tutorials. So with that, I want to open it back up to discussion and let more folks have the opportunity to comment.
Hi, Dimitri. This is Andrew. I had a couple of thoughts. I think this is great. One thing that I've observed is people don't know. I think what people might need help with more is the what rather than the how. And so, what you've shown us is a way to explain how to do things, which I think is, obviously people need help with that. But what seems to me to be quite hard for people to grasp, and what would be really useful, is to understand what someone actually needs to do as a consultant, or even taking a step back. What are the project decisions that are trying to be made at each phase of design, and how can you as a consultant play a part in making those project decisions better? So So like, rather than sort of framing it initially in terms of, oh, here's how to study the climate, it would be like, okay, you know, the massing has to be resolved, right? That's what has to be done. And how you can help resolve the massing is by understanding like the best places to put windows.
Yeah, so that is definitely what we're.
And that's what I would describe as the what.
Yeah.
Sorry, you go.
Yes, that's definitely what we're envisioning here. So the idea is we try to identify these design tasks and then layer on modeling tasks that could be done to inform these. Within these modeling tasks, we're trying to provide specific guidance on what you as the modeler can do to inform the design task. So that is definitely the concept. And if we need to name the modeling tasks in a way that makes it clear, like this is specifically what you're trying to do, then we certainly will try to do that to the extent possible.
So Dimitri, do you think we can have this kind of map interactively on the website? And for each of these, there would be kind of an article that kind of explains both the what and the how. And that way, if someone wants to do the whole process, they just go through it. And, like they can know if they missed something or not, because that's kind of one way to approach it. Because I totally agree with Andrew that the what really is what's really missing with a lot of people, and not really just the how. Because, and if we can have that kind of like an interactive map, and you can, just go into each one, and each one would have an article that explains it, I think that would be kind of really awesome.
Yeah, I think it absolutely could be done. The tool I was using to prototype, did not let me do it. So, it's more of a text-based approach that I was sharing with you today, but this is definitely something we've talked about in some of our project meetings, is this kind of visual navigation approach.
Yeah.
Hey, Dimitri, it looks like Stacy has a question.
Okay, go ahead.
So I'm gonna cheat a little bit. I have a two-part question, actually. And my first one is maybe easier than the second. And that was, what is the desired shelf life for the project? It looked like you had a lot of embedded links and you were referencing kind of specific tools. And those tend to evolve pretty radically from one year to the next. So what's the shelf life of this?
Yeah, it's a great question. You want it to be useful regardless of when people click on the links. I found when I was researching available content that's there currently out there in the world, that whenever you find a list of links, inevitably some of them will be broken links. So it's a tricky one. I think that we have talked amongst our project team about trying to focus on things that are not likely to change. So there is a heavy emphasis on describing design tasks and how modeling helps to inform them, helping to describe the building physics, the underlying building physics principles. Those things probably don't change so much over time. Once you get into specific tools, then things can get out of date pretty quickly. So it's still an open question of how much do we want to talk about things conceptually versus specifically. So I'd love to hear your thoughts on that.
Okay, and then my second question goes back to something I can't remember if it was Rand or Chell or somebody else entirely asked the question about who it, and the answer was somebody aspiring to or either is a building energy modeler, but I'm wondering to what extent that is how they sort of define themselves. So I'm an architect. We have embedded versions of energy modeling in our workflow, but if you were to ask me what I am, I would never say building energy modeler. So is it not for me? It's people who identify as 100% building energy modelers?
The former, not the latter. Anyone who can benefit from, data-driven decisions. You know, it could be an architect, it could be an engineer, it could be someone who calls themselves an energy modeler. It's for people who are involved in the design process, who have an interest in making better design decisions.
So, and so I think you may end up with sort of a different sort of way to represent information, whether it's text-based or sort of other kind of more graphic workflows. So that's really helpful. Thank you.
Yeah, and I do think, you know, final versions would probably have a lot more illustrations or graphics, particularly, you know, trying to convey building science information. You know, I've got little text blurbs there now, but, you know, they could absolutely benefit from graphical representations to help make the points clearer.
Dimitri, we have another question from Kristen, but then I think you're gonna have to move on as time allows.
Okay. Yeah, there's definitely a few questions that we want to pose and get feedback on, so I think that's a good plan, Mike.
So mine was really quick. I was just going to say that I think this project timeline, and particularly linking it to the phases of design that we teach in school, will really help people that are coming out of school or are still in school. So I think this is exactly what I would want to do in a classroom setting. But I would also say that with my consulting hat on, this probably wouldn't be the easiest way to approach. So I think that to the earlier comment of if you can even funnel people when they first enter, who are you, how do you identify yourselves? I think people are going to look for very different organizational schemes depending on how they're coming to and approaching the problem.
Yeah, that's a great point. So thanks for that.
I guess me, Alfonso. I was wondering if there's any value on kind of in that mind map that you had, maybe regionalize some of the strategies, because no building, no workflow for designing a building will be the same in every region. I mean, designing a building in Anchorage is not the same as designing a building in San Juan, Puerto Rico, or in Phoenix or in Seattle. So I wonder if we can also suggest, you know, certain points of attention that need to happen per, you know, each region, or each major region, or each I don't know, latitude maybe, or something like that.
Yeah, no, it's a great question. You know, one of the thoughts I've had on that particular topic is, you know, how do you recommend things that will work in one place versus another?
Mm-hmm.
So, you know, some of the thoughts I've had is, you know, ASHRAE put out their advanced energy design guides that have done a pretty thorough analysis of various building types, how to make them efficient in various climate regions. So maybe there's some way to extract information like that that says, well, you know, if your project is in, you know, Texas, you know, maybe, you know, it's too hot for operable windows and natural ventilation. But you know, if you're in the Northeast, then, you know, maybe it is appropriate for sometimes. So that's, you know, one thought I've had on the topic. You know, how do you serve up relevant recommendations? You know, it begins to become a very difficult question to answer, and you know, maybe it's something we can push people in the right direction through this work, and then you know, teach them how to use the tools to test those strategies themselves. I don't know the answer, but I do think that giving people at least some preliminary guidance would be quite valuable.
Great.
Isn't that the point of the analysis, though? Aren't we trying to guide and educate people about how and what analysis to do, and not necessarily what the solution should be? Because, I mean, to me, the process for guiding a building through design decisions should be the same regardless as to where you're at. That's why you're doing the analysis. You know, whether you're in climate zone 1 or climate zone 6, you're still doing load reduction. Now, the outcomes are going to be different, but the question you're asking, the analysis that you're doing is ultimately the same, right?
Yeah, but that's me and you that know it. But somebody who's just fresh in the field won't know this, right?
Yeah, I tend to agree that it's really difficult for, especially the newbies, like, well, what measure should I even be thinking about? If you haven't done it before, you don't know necessarily where to start. So I think, as I said before, giving people some places to look for guidance would be helpful, but also, to pick up on the previous comment, identifying that it's not the answer, it's directional guidance.
Mm-hmm.
Following up on what Alfonso just said, like I think climate consultant does something like that. It gives a number of strategies that you can use, and then you can try out with all of that. But then you don't have to go through like 100 of all of them, and that just shortlists a number of strategies for you. Maybe he is referring to something like that.
Yeah, and one of the things on that climate analysis example was, I didn't share it with you, but there is at least placeholder for identifying appropriate design strategies for your climate. So that's content to be developed, but I think it does get at what we're discussing here now. But I do want to move on because we need to get some very specific feedback from the tag, and there will be an opportunity for more discussion at the end. But we're really running short on time, and I want to make sure we don't miss out on this opportunity to get your feedback. So the second topic here is to discuss the scope of the website. And we want to know your thoughts on what should be included in the site, which phases of design. We showed the timeline graphic, but is it appropriate to go all the way through the operational phase, or should we stop short? So Mike, why don't we fire up the live poll and let people vote on this? There's actually a couple questions here. The first one is about which phases. The second is, should we include those sort of fundamental knowledge topics? And the third is, should the scope cover more research-focused things that are outside of a design project? I'll give it a minute or so for people to vote. All right, looks like most 80%. Folks have voted. How do I share this on this?
Well, when I end it, so everybody wanted to vote could vote. So now you guys can see.
All right, great. So there we go. The early phases through DD, people definitely support that. Things start to taper off a bit once you get to CD. You guys must be doing a lot of post-occupancy modeling, or maybe that's just a hole in the knowledge that's out there. So fundamentals, looks like there's support for that. And yeah, research, it's a little bit of a split. Okay, cool. Thank you for that. All right. Okay, yeah, and as I mentioned earlier, one of the things that I'll be sharing with you as a follow-up to this meeting is asking for your help to review that timeline graphic. I've fleshed it out through DD. It gets a bit more conceptual once you get into the CD phase, because I kind of shared the opinion of a lot of you that the early phases should be the priority. So I think we're generally on the same page there. Now the next topic for your feedback is now that we've kind of got this concept pulled together, we are going to try to develop some example content for your feedback during future tag meetings. So now I've listed a few topics to choose from here. And the hope is that you can vote on your top 3. And I'll quickly walk you through them. The first one is sort of general. For each of the items on that timeline, we could develop a very high level description of what that modeling task is. So even if there's not a detailed tutorial, at least people can like click on it and see, well, what is this all about? And detailed content would follow in the future. But then the detailed content development would be covering things like pre-design tasks, the climate analysis, flesh out the example that I shared with you, give people some guidance on how to do energy benchmarking and target setting. In conceptual design, provide some guidance on how to support a design charrette, how to do massing analysis, what things you should be considering there. Introductory content on how to do parametric analysis. In schematic design, looking at energy impacts associated with zoning a building, some guidance on shoebox modeling, probably for specific subset of analysis. How to do EUI estimation and how to account for uncertainty, during these early phases. And then in DD, the example I listed here is how to analyze and help to design wall sections. So we've got another live poll. Pick the top 3 and we'll see what you have to say about that. And while you're voting, if there's something that you really think should be done first that is not on this list, shoot me a note and send me your best argument and we'll consider it. I'll give another 10 seconds or so. Get those clicks in, guys. All right. All right, great. So Mike, if you close it out, you can kind of see what we've got here. All right. Pre-design task, energy benchmarking and EUI, target setting, conceptual design supporting charrettes, conceptual design massing analysis, intro to parametrics tend to be the top vote getters. So thank you. We'll definitely be looking at this feedback to help guide our next steps here. So thanks. Okay, let's see. Okay, so I also want to point out that we do have some other data we'll be considering to help the prioritization process. During the interview project that I mentioned earlier, we asked practitioners what modeling use cases they are doing most often. So this should provide us some additional insight into what topics are important to cover. Also, ibpsa-usa conducted a poll last year asking its membership to prioritize their needs for training. So, the nature of ibpsa's membership tended to show the need for some more advanced concepts, but actually the top 2 vote getters in that poll were for early phase analysis and guidance for effectively presenting results. So even for more advanced modelers, there's definitely a need for what we're talking about here today. I'll wrap up by giving you an overview of the project schedule, starting with the short term. So today, we gathered your input on prioritization. Thank you so much for that. Over the next few weeks, we'll be hoping to get your feedback on that design and BEM task timeline, which we'll share with you as a follow-up to this meeting, along with meeting notes. Over the next few months, we'll begin to develop drafts of the prioritized content. And then the next tag meeting, which will be later this year, probably towards the end of the year, we will share the draft content with you for your review and feedback. And likely that would be in the form of documents sent around for review and comment, but we'll follow up with more detailed information on that when we get closer to it. Looking out into the long term, our hope this year is to sort of finalize the concept and develop some prototype content. Next year, we would try to develop a useful subset of modeling use cases so that we can put this thing out in the world and allow people to start to use it in a kind of beta sort of phase. And then, in future years, continue to expand the scope of modeling use cases so that the content is as robust and complete as possible. So that gives you a bit of insight into what to look forward to. So we do have a few seconds left before time runs up. I'm happy to stay on a little bit longer if there's any closing comments that folks would like to make.
I think this is great, and I think it's also important to understand the integrative nature of the design process itself, and how we can use the analysis that is done in an early phase of design and take it forward to design development. It's important to create links in our resources so that so if we are doing a natural ventilation analysis in the early design phase, how we take it forward to the design development phase, and what are those links.
Yeah, absolutely. Great comment.
This is Chell. I think energy modeling is a great title for something, but carbon modeling is something that people are more and more interested in. So understanding how to model for carbon is good. NREL is coming out with Cambium later this year, which should help with kind of carbon association with different grid regions modeled over the next several years. So I think figuring out how to get carbon in the picture, because people are going to ask more and more about it. And actually, once incentives and dollars are unlocked for carbon, I think that'll be more and more part of what has been called building energy modeling.
Great, thank you. Before people start to jump off, here's my email address at the bottom of the slide. Feel free to share any thoughts, comments, etc. After we wrap up here. Your input's been really valuable, and I'm sure as you begin to look at the content we share with you, you'll think of many things that we haven't yet, and that's why we've put together such a broad group with varying expertise. So thanks everybody so much for your time here today. Again, I'm happy to stick around for a little while longer if there's anything else that people have on their minds that they wish to share. But before folks need to drop off, I wanted to make sure you had my email address so you can reach out to me.
Yeah, I wanted to say thanks, Dimitri. I've noticed that we have a propensity to stick to details that we're most familiar with, and from viewing various funnels and SEO over a decade or so, I think that we have this large tree that you've established, and the primary goal is to make that a linear, to appear linear to the end user, and walk that linearly. And the other issue is that we've learned over time is that people need to know what they need to know, and what they want to know are different things. And the goal is to find a balance in between that as well, in that tree, to make it seem linear to them. And if they want to dig into details, those can be added. We don't have to add the necessary details to a specific topic. It could just be, coming soon or something like that. Once we have some sort of, I think the common term is funnel, but a funnel ultimately is a tree that appears linear to someone. And I think you see that, but we don't want to get caught up in too many details right now, in my opinion. I think the definite thing is you're on the right track, and we want to focus on user experience without overwhelming them. So that's all. Anyway, nice job and a lot of footwork for you so far. So appreciate it.
Thank you.
Yeah, this is super exciting. I'm really interested to see, where it goes from here. I think a couple of thoughts. One is, going back, and a number of people have talked about this whole idea of kind of using this to frame questions. We can always get to the answers, but really, the important thing, especially early on, is framing the questions and getting us kind of in the kind of engaging more with the design team. Understanding design intent is really important. And then, one of the other things that I remember years ago, I was working on a project with the design lead partner in charge in an office I used to work at. And I was presenting this data, and he turned to me and he had two words, and it was, "So what?" And it threw me completely, and I was thinking that he was actually just kind of writing me off. But it was actually an important question. It's like, why is this important? And so I think it's important to kind of add the "so what" filter to everything that we're doing here to understand what makes it important.
Vikram, I can't agree more. I remember that, and again, I'm still a student, but I recall in my third year of undergrad, they gave a workshop at our school that gave Design Builder. I mean, by third year in architecture, you do understand that sustainability is definitely important. But the professor came, and he was a very talented individual, but he was teaching us how to run the simulations. But as people, as students in the third year of undergrad, we really didn't understand what was so important about, putting the HVAC system there, or what the infiltration rates are. So it was kind of, he was just taking us a step by step. And the whole workshop was like, press this, press that, press this, press that. And by the end of it, we all forgot everything that we took in that workshop the next week. And not until I, went to graduate school again, and I had sought the information out after, learning a lot more, then I rediscovered my passion for it. So I think really, yeah, that "so what" kind of factor is really what hits everyone, because there you can find a lot of really good tutorials of what to press and all that, but it's the importance and I mean, at least to me, it's kind of the building science fundamental aspect to it of why we need to do this is what really I think should make this a bit unorthodox and not the usual just a general wiki for like modeling, because unmet hours can answer most of my questions for modeling. But if you don't really know what to search for, it's worthless, to be honest. That's kind of how I kind of see it.
Yeah, and if the end goal is to move us, because right now in the design process, we're not in the center of things. We're kind of at the fringe, whether we like it or not. So if the intent is to move us closer to the center and be, guiding or, sometimes hopefully driving the process, then you have to ask yourself, what is it that we need to get us there? And the first fundamental thing is we need to get designers to be thinking about data and, the stuff that we produce. But conversely, we need to be thinking about design as well. And so I think there's room for some, non-technical maybe aspects to this to kind of educate ourselves on, what is it that drives the design process? How do we, design is a research question, but research is a design question as well, right? And so thinking about that kind of cyclical nature, the codependent nature of that is really important.
Like kind of a how to work with an architect.
That's why
segment
the content is organized around the design process, because the design process is going to happen with or without modeling. If we as modelers understand what we can do to really meaningfully play a part in the design process, then we can have a greater impact. And if the design team understands what modelers can do to help them make their decisions, then they know when to call us. It's not this kind of question mark like, well, it's not time for my lead model, so like, why is it bothering me? So like the hope is that we can educate each other and be speaking the same language and work together.
Cool. great effort. I think this is a super exciting project, and thanks for inviting us.
So a segment called How to Work with an Architect might be a good segment to add. And might be an early developed segment as well that might inform other segments.
That's a great comment. Yeah, I think that maybe falls in the fundamental knowledge category, or we'll definitely put it on the to-do list.
Yeah, about a good percentage of the AIA Guide to Building Performance was how to work with an energy analyst. And I could see, you know, the reverse of that in this one, how to work with an architect.
Yeah, talk really slow.
Also,
I'm an architect. Huh?
Also, how to transfer your models to an engineer when it's time to size systems and, you know, go outside of your own liability. I've been seeing a lot that engineers, I mean, because of just the process of how a project goes, SD, DD, CDs, we start a project, we architects start a project, and then the engineers sometimes don't get on board until probably the middle of DDs. So there's all that gap in the process that is not covered by anyone, and has to be covered by us in the architecture field, in order to, you know, have integrated solutions to our projects, and then transfer our findings to an engineer when they come on board and they need to size their systems and, you know, put their stamps on the drawings.
Yeah, that's a really good point in terms of like the time lag is often, you know, and sometimes we get so head up about being exactly right that, you know, about not being wrong, that we don't have enough time to be right, if that makes sense. So it's, you know, timeliness is sometimes more important than, you know, dead on accuracy, just in terms of like being able to move the needle. Yeah, it's almost like what you need is almost like a value statement up front to say why this is important. So to someone coming in, it's like, why should I care about this? Why is it important? Why should you be thinking about, you know, performance modeling? And, you know, it's more than just, you know, energy, it's more than just BTUs, it's about performance, right? And so maybe there's a semantics thing there, because it's about thermal comfort, it's about, you know, other aspects that sometimes, you know, designers care equally or even more about. And so kind of framing that question of, you know, why should you care about this, I think is really important.
Yeah, Dimitri, how is this different from the BEM book initiative that ibpsa started a while ago?
Yeah, so it's a great question. BEM book, you know, I kind of alluded to past efforts that kind of fizzled out. BEM book is kind of geared around capturing information on BEM topics. So, you know, I gave you the example of weather data, you know, actual, future, etc. Well, that's a pretty good example of something that appeared in BEM book. In fact, a lot of that content, you know, I just grabbed from the BEM book and attributed it to that. But in terms of how to execute specific modeling tasks and how those relate back to the design process, I think that's kind of the new idea here, is really trying to ground it in a project context.
Cool.
Dimitri, this is Bill Burke. You know, one thing, I agree with the comments everyone's been saying about so what and why. I know that some architecture firms that value energy modeling, and I'll just throw out a couple of names, and I know there are many, many others, but I know EHDD, for example, or a firm like Lake Flato in Texas, they actually have, I have people at those firms have told me that when they procure an HVAC member to their team, they actually have a description of these are the energy services that we're looking for in the project. Here's what we want, when we want it, and why we want it. And so to sort of try and get at that question of, you know, so what or why, you might just ask some of those firms if they could share that with you. Again, I mean, you've said this is for people trying to learn energy modeling. So, you know, it can't be everything for every group, but I'm just thinking that, you know, understanding from the architects, from a good architect's perspective, what they want in terms of energy modeling and why might assist you in this whole issue of, well, if you're an energy modeler, how do you work with an architect? If nothing else, it might suggest that here's what some leading firms are doing. If you're working with somebody who's not a leading firm, you might be able to communicate to them from some of these guidances from leading firms as to why they want energy modeling services and maybe beyond services that they're used to, such as a compliance model or a lead model.
It's a great idea. I may follow up with you, Bill, to get some contact info from folks that you think might be helpful. Absolutely, folks on this call, if that's something that you have some, you know, information to share.
Yeah, Element Architects, we incorporate ASHRAE 209 certain cycles into our RFPs for mechanical / energy analyst consultants. But then also there was an effort that I don't know, some people on this call were on, I know Kim Chin was part of as well, where a group of us, and I think it was convened under AIA, was attempting to write the kind of scope of work RFP so that architecture firms could use it. And I feel like it was incorporated into some AI document, not the contract document, but some other document. So I can dig that up and send that.
Wonderful, thank
to you, Dimitri.
Bob, you're a dinosaur.
Yep. We at Gensler, what we're trying to do is actually have targets for EUIs and LPDs, and you know, just circulated that firm-wide. So we're encouraging every team to actually meet those targets, and then by themselves they are noticing that they need to have early modeling incorporated into the process, and that's essentially job security for me, I guess. So they need to be aware of you know, what their EUI is, you know, the moment they start modeling and testing things and, you know, presenting things to the client.
All right, guys. Well, we're definitely over time. So thank you so much again. This has been really helpful, and I think it gives us some good guidance on how to move forward. We'll certainly be following up soon with much more information, more than we could.
Dimitri, will you be sharing the content you showed us with everyone?
Once it's in a more complete state, yes. You know, at this stage, it was really meant to illustrate the concept and the organization.
Yeah, I'd love to take a look at it in more detail.
Yeah, but definitely, that's the goal, is to flesh some of these examples out and then get your input and feedback.
Thanks. Cheers.
All right, folks.
Thank you, Dimitri. This was great.
Yeah.
Thank you.
Thanks, everyone.
Thanks, Mike and Dimitri.
Yeah.
Bye.
Bye.